All right, let's talk a little bit about rotational symmetry, or rotating something so it lands in overlaps where it used to be. So I have a little gizmo here that does not work on an iPad. So it's something where I kind of have to show you based on me doing it. So I have a hexagon here. It's a regular hexagon, all the sides being the same length. This is where I'm going to actually like turn my figure around. So like I would envision putting a pencil tip right there. So when I rotate it, it's going to rotate around that. Now the goal is for it to land exactly in the same spot that it was. So you can see that there is this outline of where it used to be, and it's not overlapping perfectly. So I'm going to reset it to 0. That was a 30-degree rotation. 45-degree rotation's pretty close. 60-degree rotation all the way around. Lands it right over itself. And that was 6 turns, I think, to get me, you can see a little counter over here, to get me back to 360 degrees. So it turned 6 times to make 360 degrees. The angle of rotation had to be 60 degrees because each of those 6 times, 60, would get me 360 degrees. So imagine this, which is 1, 2, 3, 4, 5, 6, an octagon. How many degrees do you think I need to turn this so that it will land onto itself? Try 15. No. 30. No. What's the way we could calculate this? Well, you figure we're going to be turning it, and as we turn it, it'll turn 8 times around and lock into place until it's back to 360 degrees. So 8 times, and we got to get to 360. 360 divided by 8 is how much? 45? Four times to get to 180, 7, and 8 times to get right back to 360. So it can turn 8 times, and the angle of rotation would be 45 degrees each time. Now, are you noticing where I'm getting this 45-degree rotation from? I'm dividing, but also look at this equilateral triangle. Think back how many degrees are in each of these interior angles. So there's 180 degrees in a triangle, and these are all equal, so they got to be 60. What is the exterior angle? Remember, the interior and exterior have to meet at 180 degrees. So if its inside is 60, the outside is 120. I wonder if we set it at 120, if it'll land perfectly onto itself and turn 3 times till it gets back to 360 degrees. So one turn and it maps directly onto itself. Another turn of 120 degrees, it maps directly onto itself. And another maps right onto itself. So there's a couple different ways to do it, but it's also the exterior angle as well. Or 360 degrees, you got 3 times you know you're going to turn it. And so we know then 360 divided by 3 is also 120. So the next worksheet's going to involve doing lines of symmetry again. Keep in mind a line of symmetry cuts it perfectly in half. And it also can go in that direction. If I rotate it, you can see the other lines of symmetry. There's one going that way, one going that way. There'd be 3 lines of symmetry in this 3-sided figure.